This is problem number 6 from section 3.7. In this problem it says use implicit differentiation to find dy over dx and d squared y over dx squared using the following equation. They give you 8 root y equals x minus 3y. Again, this is not written as y as a function of x, so we have to use implicit differentiation to do this problem. That means that when we take the derivative of y, we have to put a dy over dx at the end. So let's rewrite this real quick as 8, this is y to the 1/2 equals x minus 3y. And now let's take the derivative from left to right. So we'll do the derivative of this here, and the 1/2 comes to the front. 1/2 of 8 is 4. So 4y to the negative 1/2 dy over dx, because I took the derivative of y, equals derivative of x is 1, and the derivative of negative 3y is minus 3 dy over dx. Now we need to solve for dy over dx, so that means I need to get it on the same side. So let's go ahead and write this as 4y to the negative 1/2 dy over dx. I'm going to add this to the other side, so I'm adding 3 dy over dx to this side, so that's plus 3 dy over dx equals 1. Let's factor the dy over dx out, and we get dy over dx parentheses 4, this is not negative, so parentheses 4 y to the negative 1/2 plus 3 equals 1. And then let's go ahead and divide this over, and we end up with dy over dx equals 1 over, this will be 4y to the negative 1/2 plus 3. So if we wanted to, we can simplify this a little bit further, because we have y to the negative 1/2 on the bottom, so we have to write this over root y technically. What we could do to just simplify this whole problem, let's multiply the bottom by y. So if we multiply the bottom by y and the top by y, we should be able to cancel out this y to the negative 1/2 power. So it's just y to the 1/2 power. So we're going to multiply the bottom by the top by y and the bottom by y. Actually, you know what? We're going to multiply the top by y to the 1/2 and the bottom by y to the 1/2. And that'll cancel this out. So we're going to get dy over dx, I think I can write it here, yep, dy over dx equals y to the 1/2 on top over, when you distribute the y to the 1/2 to each term, this y to the 1/2 will cancel this one, so we're just left with 4, and then we'll get 3 y to the 1/2, which gives you, this is root y over 4 plus 3 root y. So that's the simplified first derivative. So now they want us to find the second derivative. Let's go ahead and write this up here. This is dy over dx, so this we're going to say is d squared y over dx squared. So I'm taking the derivative of this function here. Now I'm going to have to use the quotient rule, and remember the quotient rule, we're going to have to split this function up into a numerator and denominator essentially. So this is u equals root y, u prime, v prime, v is 4 plus 3 root y. We take the derivative of root y, that's going to be 1/2 y to the negative 1/2 dy over dx. We take the derivative on this side, and we'll bring the 1/2 to the front, so we end up with 3 over 2. Remember, derivative of 4 is just 0, so we end up with 3 over 2 y to the negative 1/2 dy over dx. And then we pull out the quotient rule. The quotient rule says u prime v. So we're going to take this times v. So we're going to end up with, let's go, 1/2 y to the negative 1/2, which, yeah, I'm going to leave that as so, y to the negative 1/2, instead of writing as root y or anything like that. So this is dy over dx. And we're multiplying that times v, which is 4 plus 3 root y, minus v prime, so minus, we're going to write this out, so this is 3/2 y to the negative 1/2 dy over dx times this root y. So I'm going to write that as just y to the 1/2. And I probably should have written this radical as to the 1/2 power. We'll do that in the next step. Over, so we end up with v squared on the bottom, which is 4 plus 3 root y squared. I'm going to leave myself a little bit more room as we go to simplify all this. So d squared y over dx squared is equal to, we need to distribute this term to each of these terms. So when we do that, that's going to give you, well, 1/2 times 4 is just 2. So I end up with 2 y to the negative 1/2 dy over dx. And now I'm multiplying this times 3 root y. Now remember, this is y to the 1/2 power. So I take y to the 1/2 power times y to the negative 1/2 power. That becomes 1. They cancel out. So I just end up with 3/2, so plus 3/2. And then I still have the dy over dx. So this times 3 root y, the root y and the y to the negative 1/2 cancel, and the 1/2 times 3 is 3/2, and I still have dy over dx. And then on this side, we need to multiply these together. Well, I'm just going to end up with minus, the 3/2 will stay there, and the y to the negative 1/2 and the y to the 1/2 cancel, so I just end up with dy over dx here. And this is all over 4 plus 3, this is root y squared. Now you can see that this is going to cancel. So we end up with d squared y over dx squared equals, I need to plug in this dy over dx for dy over dx here. So I have 2 y to the negative 1/2 times dy over dx, which is root y, over 4 plus 3 root y. And that's all over 4 plus 3 root y squared. So d squared y over dx squared is going to equal, remember this is y to the negative 1/2, so it's technically like, let's write that out, that's 2 over root y, so we have a fraction 2 over root y times root y over 4 plus 3 root y all over 4 plus 3 root y squared. What happens here? The root y's are going to cancel, and we're going to end up with d squared y, derivative of y with respect to x, second derivative I should say, is going to be 2 over, we end up with 4 plus 3 root y all over 4 plus 3 root y squared. Well, if I divide by 4 plus 3 root y and then divide by 4 plus 3 root y squared, really I'm dividing by 3 of those. So this is second derivative of y with respect to x is going to equal 2 over 4 plus 3 root y cubed. So this is our first derivative, and this is our second derivative.